performance objective. And today we are going to learn to convert angles measured in degrees, minutes, and seconds into decimal degrees. We are also going to learn the trigonometric values of special angles by heart. 0 degrees, 30, 45, 60, and 90 degrees. These are special angles. We need to learn these by heart. The reason why we need to learn this by heart is because there are some calculators, and the calculators where we give you are not calculators that will express them in fractions. We need them in fractions and in surd form, and so we need to learn to know them by heart so that when we punch our calculators and give us in decimal, we already know the values in fraction. And finally, we are going to solve right angle problems with the use of Pythagoras theorem and SOHCAHTOA. This has been learned before, so we're going to refresh our memory on that. Now to today's lesson. Trigonometry is just the branch of mathematics that deals with triangle. That's why the 3 is present. Tri means 3. So triangle, 3 lines. And of course, when we have lines coming together, we have angles between the 2 lines. So now we are going to deal with angles majorly. When a straight line is rotated about a point, it sweeps out an angle that can be measured in degrees and radians. By convention, a straight line rotating through a full angle and returning to its starting position is said to have rotated through 360 degrees, where each degree is subdivided into 60 minutes, and each minute further subdivided into 60 seconds. Any angle less than 90 degrees is called an acute angle. An angle greater than 90 degrees but less than 180 is called obtuse angle, while an angle greater than 180 is called a reflex angle. Now, let me quickly explain what this means. A straight line rotated about a point. We can have a straight line this way. As soon as we rotate this line, that means we now cut it this way. This is the angle made. The measure of the distance, angular distance, between the first line and the second line is what we call the angle. So angle is just the measured distance between 2 lines intersecting. So these angles can be measured in degrees, like 50 degrees, and in radians. Usually radians have the pi, so we can have like 2/3 pi rad. We see something like this. This rad is just the unit for the radians, and this small 0 up is just the unit for degrees. Okay. We said when we have angles less than 90 degrees, those angles are called acute angles. 90 degrees is meant to go up this way, a perpendicular line to the first horizontal line we've drawn before. And so since this angle is less than 90 degrees, this angle is called the acute angle. This is angle 90, which is called a right angle. Okay, now also we said an angle that is greater than 90 but less than 180 is obtuse angle. So it means this is a straight line extended. We're going to have 180 degrees, but if we have an angle that is not up to 180, that is, the line is greater than 90 but less than 180, this angle is called obtuse angle. Obtuse angle. All these have been learned in basic mathematics. And finally, we have the reflex angle. This angle is greater than 180 but less than 360. So as soon as I bend this line downwards this way, this angle is called a reflex angle. This is a reflex angle. So these are the three major types of angles that we have. Okay, now, lastly, I said angles in degrees can be split into hours, minutes, and seconds. Hours, minutes, and seconds. For instance, when we have 50 degrees, 30 prime, 13 double prime, or 13 prime prime. This can be converted into full degree. It can be converted into full degree. In what manner? We have 50 already in degrees. This 30 is in minutes. You'll notice, for those of us that like watching football, after 45 minutes or after 90 minutes, you'll notice the right plus 3 or plus 5. This means plus 3 minutes plus 5 minutes. That's exactly what we can relate this to. So this minutes, converting minutes to hours, is just going to be 30 divided by 60. And converting seconds to hours will be first by conversion to minutes, divide by 60 to convert to minutes, and then divide again by another 60 to convert to hours. So this takes us to the next slide. We simplify the problem and we get our final answer. Now, let's look at this first example. An angle that is measured in degrees, minutes, and seconds can be converted to degrees in decimal as follows. We have 45 degrees, 36 minutes, 18 seconds. (35 degrees, 36 minutes, 18 seconds. We need to convert this to full degree or degrees in decimal. Now, like I said before, this 35 is already in degrees. 36 is in minutes. We need to convert it to hours. Hours is just equivalent to degrees. So we have plus 36 divided by 60. And then finally, we have 18 divided by 60 times 60. So we have 35 degrees plus 36 over 60 plus 18 over 3,600. Okay, now we can say this is going to be 35 degrees plus 36 divided by 60 is 0.6, and 18 divided by 3,600 is about 0.005. When we add all this together, we should have 35.605 degrees. So when you are given angles in this format, we should be able to, we of course can use this one in the solution to problems. This is just to make sure that we don't have decimals in our values. But when we are given this and we want to use it to solve a problem, we have to convert it to decimal first before we use it to solve a problem. So this is the exact way to get it. Now we are going into some special angles. We've all heard about special angles. Some special angles like 0 degrees, 30 degrees, 60 degrees, 90 degrees. Now, our teachers in various schools have been telling us we need to learn this thing by heart. But, of course, it is somehow somehow hectic for students to learn. Let me say you learn it today, you forget tomorrow. But this is a simple technique to easily remember. We have the thumb, the index finger, the middle finger, the ring finger, and the pinky finger. Don't mind my diagram. Starting with this, we're going to have, because sine starts from the smaller value up to the larger value, while cosine works in the reverse. So we're going to have 0 over 2, and then the next one is going to be root 1 over 2. The next is root 2 over 2, and the next is root 3 over 2, and the next root 4 over 2. Okay, let me use a brighter color. These are the values that we need to take note of. Root 0 over 2, that's 0, 1, 2, 3, 4. We have root 1 over 2. We have root 2 over 2. We have root 3 over 2. And we have root 4 over 2. Remember, all of them are divided by 2. So we pick the fingers one after the other, starting from 0. 0, 1, 2, 3, 4. The numerator always have the roots. Of course, this root 4 over 2 is the same thing as 2 over 2, which is equal to 1. Now, let's go back to the special angles we talked about. What are the special angles? We have 0 as the first special angle. We have 30 degrees as the second special angle. 0 degrees, 30 degrees. We have 45 degrees. We have 60 degrees, and finally 90 degrees. So, like I said before, sine goes forward while cosine works backward. What I'm trying to say is this: sine 0 degrees is equal to 0 over 2. What is root 0 over 2? Root 0 is 0, and then 0 over 2 is 0. Sine 0 is 0. You can confirm with your calculators. Sine 30 degrees is equal to, the square root of 1 is 1. So that's the same thing as 1 over 2. Sine 45 degrees is root 2 over 2. Sine 60 degrees is root 3 over 2. And sine 90 degrees is equal to root 4 over 2, which is the same thing as 2 over 2, which is also 1. Sine 90 is 1. And like I said, cosine works in the reverse. So if we are dealing with cosine, we just say cos 0 degrees is equal to, begin to pick the values back from down, or take it back with your fingers, take it backwards. Root 2 over 2, root 4 over 2, which is 1, cos 30 degrees is equal to, take it backwards, we're going to have root 3 over 2, and then cos 60 is 1 over 2, cos 45 is the next degree, cos 45 is root 2 over 2, cos 60 is equal to 1 over 2, and finally cos 90 is equal to 1. So, without stressing yourself too much, just take note of the first, second, third. Always start from 0. So we have 0, 1, 2, 3, 4. The numerator always have a root, and the denominator is always 2. Take note of that. And then the angles, begin to increase them. Increase the special angles from 0 to 30 to 45 to 60 to 90. Then with all this, you can easily simplify problems and write your final answer in surd form or in fraction. Sometimes the answers will be required in surd form or fraction. This is an easy way out. Now, we are going to use this to solve some problems. Sine increases while cosine decreases. That's what I just explained. From the finger style, it is deduced that sine 0 is equal to 0, and it keeps going on like that. Now let's solve this first example. Given that sine x is equal to 3 over 5, find the value of cos x, find the value of tan x, find the value of sine squared x plus cos squared x. Now, we're going to be using these right angles to solve problems. We're given that sine x is equal to 3 over 5. Let's recall from SOHCAHTOA. Sine theta is equal to opposite over hypotenuse cos theta is equal to adjacent over hypotenuse, and then tan theta. The theta is the angle, is equal to opposite over adjacent. So, sine x is equal to 3 over 5. What this is telling us is that the opposite over the adjacent, opposite over hypotenuse, is equivalent to 3 over 5. So we can simply draw a right angle triangle. Of course, always remember that Pythagoras theorem and SOHCAHTOA deals with a right angle triangle. If the triangle is not a right triangle, don't ever use SOHCAHTOA, don't ever use Pythagoras theorem. Now, this is our x. Since sine x, the sine of this angle is equal to 3 over 5, and sine is opposite over hypotenuse, it means that the sine of this angle is opposite, which is 3, so put it there, over hypotenuse. Hypotenuse is the longest side, or the side facing the right angle, 5. The question now says, find the value of cos x. What is cos x? From SOHCAHTOA, we can deduce that cos x should be adjacent over the hypotenuse. And if we have the opposite, we have the hypotenuse, it means the third side must be the adjacent. But what is there? We don't know yet. So we need to use Pythagoras theorem to find out what the adjacent is. So we can solve the problem here. Remember that from Pythagoras theorem, hypotenuse squared is equal to opposite squared plus adjacent squared. So our hypotenuse is 5. 5 squared is equal to opposite squared, which is 3, plus adjacent squared. We don't know what that is. That's what we are looking for. So we can have 25 minus 9 is equal to our adjacent squared. This is 16 is equal to adjacent squared. If we take the square roots of both sides, solve the formula, we can now have 4 is equal to adjacent. Now we can put our 4 here. So automatically our cos x is now equal to adjacent over hypotenuse, which is equal to 4 over 5. That's the final answer. And from this triangle also, we can solve the second problem, which says find the value of tan x. Don't forget that tan x is equal to, okay, let me write adjacent over hypotenuse, which is equal to 4 over 5. Now, our tan x is also equal to opposite over adjacent. From SOHCAHTOA, we can remember that. So, our tan x is equal to 3, which is the opposite, over 4, which is the adjacent. We can leave the answer like that, and we can simplify to give the answer in decimal. So, I'll wipe this off apart from the diagram, because we'll use the diagram to solve the last problem. The last problem says find the value of sine squared x plus cos squared x. Sine squared x plus cos squared x. And that should give us, remember that sine x is equal to 3 over 5. So we are going to have 3 over 5 all squared. Let me quickly mention that sine squared x does not mean we'll find, it's not even possible to find sine square. What it means is you find the value of the sine x, and then you simplify. Sine 30 degrees all squared is the same thing as sine squared 30 degrees. Take note of that. Don't ever write this as sine 30 squared or sine square 30 squared. This is absolutely not correct, because sine, cosine, tangent, logarithm, all those are called transcendental functions. They cannot work on their own. They need the value. It's like like punching sine on your calculator and expecting the value. It will not work. What we need is sine, the sine of a particular value. Sine 30 is the same thing as 1 over 2. And so we can now say sine squared 30 is the same thing as 1 over 2 all squared, which is 1 over 4. So this is just to point out, in case you've been making this kind of problem, you've been making this kind of mistake, this is the correct way to solve the problem. And then we have cos squared x. We had cos squared x to be 4 over 5. That should be 4 over 5 all squared. This will give us 9 over 25 plus 16 over 25. Adding these two fractions together, the LCM is 25. 25 divided by 25, we have 1. 1 times 9 is 9 plus 1 times 16, 16. So this gives us 25 divided by 25, which is equal to 1. And that is the final answer, 1. So take note of this trigonometric identity. Sine squared theta plus cos squared theta is always equal to 1, no matter what the angle is, provided this is theta and this is theta. It means that the two angles must be the same. Sine square 60 plus cos square 60 must be equal to 1. Sine square 45 plus cos square 45 must be equal to 1. And it keeps going like that. Okay, let's move on to the next slide. This is another example. Given that a rod of length 10 meters inclined at 30 degrees to the horizontal. A rod of 10 meters inclined at 30 degrees to the horizontal. This is a rod inclined at 30 degrees to the horizontal. Leans against a vertical wall. Since the wall is vertical, we're going to have right angle. And so we can easily say, now, we can find the height of the wall and then the distance of the base. Let's call this letter D. Let's call this letter D and letter H. Now, recall that from SOHCAHTOA, let me write SOHCAHTOA again. Sine theta is equal to opposite over hypotenuse. Opposite over hypotenuse. It is obvious that this is our angle. When we say opposite, opposite is the side facing the angle that you are using. If you are using this angle up here, our opposite will be the D. But we are using 30 degrees, and so opposite means what is facing the particular thing we are working with. So we are using 30 degrees, so we have sine 30 degrees is equal to, opposite is H, and hypotenuse is 10. Sine 30, from the theorem, from the finger style, remember that sine 30 is equal to 1 over 2. Sine 30, 1 over 2. We have 0 degrees. The next one is 30 degrees. So we have 0 root 0 over 2, and the next one root 1 over 2. Square root of 1 is 1. So we have 1 over 2. This gives us 1 over 2 is equal to h over 10. And from here, it is very easy for us to solve. You cross multiply 10 times 1 and h times 2. 10 times 1 is 10, and 2 times h. 10 times 1 is 10, 2 times h is 2h. Since we are looking for the height, we are going to divide both sides by 2. So, dividing both sides by 2, we have over 2 over 2. 2 crosses out the 2 here, and 2 into 1, 2 in 10, 5. So the height of the ladder above the wall, above the ground, is equal to 5 meters. Always include your units. Number 1, always include your units. And number 2, always write your final answer in words. Write your final answer in words. The question says, find the height of the ladder above the ground. So you should write it plainly. The height of the ladder above the ground. The diagram was not given to us. We formulated the diagram ourselves. And so this h here was just used by us. You could as well use x. You could have used a. So that's why it is necessary to write the final answer in words. Height of the ladder above the ground is 5 meters. That's very important. And also, to solve the second part of the problem, the question says find the distance of the base of the ladder from the wall. So problem 2, the distance of the base of the ladder from the wall. We already got this part to be 5 meters. From here, we can use Pythagoras theorem. We have our hypotenuse, we have our opposite, we need our adjacent. But instead of using Pythagoras theorem, we can also use SOHCAHTOA. We need adjacent and hypotenuse, or adjacent and opposite. So in this case, we can either use cosine, which is k, adjacent over hypotenuse. We can also use the TOA. Tan theta is equal to opposite over adjacent, since we only have a variable that we are looking for. So using cosine, cos theta is equal to adjacent over hypotenuse. So it means cos 30 degrees will be equal to 5 divided by d over hypotenuse. Sorry, it should be adjacent. Our adjacent is actually d divided by hypotenuse. Hypotenuse is 10. We could have used tan too. That was what will have given us the previous fraction I wrote. But let's use cosine. Cos 30 degrees is equal to d over 10. And so, if you remember from the finger style, we had 0 over 2, we had root 1 over 2, we had root 2 over 2, so cos 30 is equal to root 3 over 2. cos 30 is equal to root 3 over 2, and that is equal to d over 10. To finish up this problem, we cross multiply. That means we're going to have 10 times root 3 is equal to 2 times d. 10 times root 3 from SOD, we know that this 10 is outside the bracket, so we just write it close to the bracket. 10 root 3. That's the highest we can simplify to. Is equal to 2d. At this stage, we'll divide both sides by 2. If we divide both sides by 2, we're going to get 10 root 3 is equal to 2d all over 2 all over 2. 2 crosses out with 2. 2 in 2 is 1. 2 in 10 is 5. So we have 5 root 3 meters is equal to d. This is acceptable when you're told to leave your answer in SOD form. So the distance between the base of the ladder and the wall is equal to 5 root 3 meters. So you should write plainly distance between base of ladder and wall is equal to 5 root 3 meters. So this brings us to the end of today's session. We are going to quickly go on a session break now. Meanwhile, we want you to compile your questions, and by the time you join us, we'll be answering any question we can, as many questions as we can. Before we go, I want you to consider solving these two problems here. The first one, convert 52 degrees 30 prime 35 prime prime to angle in decimal. And then the second, I want to simplify. If sine theta, it could be x, it could be theta, it could be a, it could be any value. So don't let this theta confuse you. We used x in our example, so it could also be theta. If sine theta is equal to 16 over 65, find tan theta. Take notes of these two questions. We'll be answering them when we come back from our session break. Welcome back. We've seen some of the answers, but let's solve them and then we'll be able to know who and who got the answer correctly. Convert 52 degrees, 30 minutes, 35 seconds to angle in decimal. Number one problem. This is supposed to be 52 is already in degrees, so we leave it like that. Plus, this is in minutes. Convert it to hours. That's going to be 30 over 60 plus 35 seconds, which is 35 over 3006 100. This should give us 52 plus 30 over 60 is 0.5 plus 35 over 3,600 is 0.0097, but you can decide to approximate to 2 decimal places, 0.01, you'll still be correct. If you had 0.0097, you'll still be correct. So altogether, this gives us 52.51 degrees. That is the final answer, 52.51 degrees. And number 2, sine theta is equal to 16 over 65. Find the value of tan theta. When you have a problem given to you like this, what is required is you write your answer in fraction. You write your answer in fraction. I've seen answers in decimal. Answer in fraction is what is required. Now, remember that I said since sine theta is equal to opposite over hypotenuse, all we need to do is draw a triangle. Draw a triangle. This is a right angle triangle. Put theta anywhere. 16 over 65. It means our opposite is 16 and our hypotenuse, this is our opposite. The line facing the angle is our opposite. And then the longest line is our hypotenuse. So we have 65. The question says find the value of tan theta. Don't forget that tan theta is equal to opposite over adjacent. So what you are required to do is find the adjacent and then say 16 over whatever you have and simplify to the smallest fraction which you can get. So to finish up this problem, we have to go back to Pythagoras' theorem. From Pythagoras' theorem, hypotenuse squared is equal to opposite squared plus adjacent squared. You'll notice that I keep writing the formulas whenever I need to apply a formula. I keep writing the formula over and over again. It's not as if we cannot just solve the problem, but it is because formulas are very important in mathematics. And if you don't write out the formula, number 1, you might get confused. Number 2, if the examiner feels like you cheated, that is a good reason why it thinks that you cheat. So writing the formula is very important. When you write the formula, then you can go according to what the formula is telling you. Hypotenuse is 65. So we just write the 65 and put the square. Opposite is equal to 16. So we just write whatever we have and plus our adjacent square because we don't know that. 65 squared is 4225. That's 4,225. And 16 squared is equal to 256 plus adjacent squared. Making adjacent squared is a formula. We are going to have 4225 minus 256 is equal to our adjacent squared. When you subtract this, we should get something like 3969 is equal to adjacent squared. Taking the square root of both sides, we're going to have square crosses out the square. So our adjacent will be equal to 63. Since our adjacent is 63, which is what is here, we can now say hence tan theta is equal to opposite over adjacent, which is equal to 16 over 63. This is what you are requested to do. Tan theta is equal to 16 over 63. Over 63. Let me write this in red. That is the final answer. 16 over 63. Okay. The first answer is 52.51 and the second answer is 16 over 63. Destiny got answer of 1.52 for the first. Well, 1.52 is not correct. Benedetta got 52.51. Yes, that's the answer to the first one. So Benedetta is correct. Go one question correctly. I'm not seeing your answer to the second one. Benedetta, we didn't see that. All right. While we get your answers and before we announce the winner, let's answer some of the questions you asked. What is reflex angle? Those are some of the questions asked. Kano asked, what is reflex angle? Well, a reflex angle is an angle that is greater than 180. Representing reflex angle, we're going to have something like this. I wish to leave this solution, but sorry, I have to wipe it. Let's note the two answers. 52.51 and 16 over 63. These are the two answers we got. So, what is reflex angle? Reflex angle is an angle that is greater than 180 but less than 360. So when you want to remember reflex angle, just remember the outer angle in your elbow. The outer angle in your elbow. This is your elbow. The outer angle in your elbow. When you want to remember acute angle is the interior angle in your elbow. So we have the interior within the elbow as the acute, and the exterior, not the exterior, rather the angle outside your elbow, that is the reflex. And of course the third one is the obtuse, the one that is neither acute and is not reflex. It's obtuse, that is within 90 and 180 degrees. That's what we call the obtuse angle. So this is what we call a reflex. So in plain words, a reflex angle is greater than 180 degrees but less than 360 degrees. So a reflex angle is between 180 and 360. Now, Abe asks a question. Is it possible to get tangent with the finger special angle? Absolutely. Yes, you're actually correct with that. We can get a tangent of any value. For instance, sine 30 degrees, cos 30 degrees. Now, there's a relationship between sine and cosine. If you find the ratio of sine to cosine, you will get tangent. The tangent of an angle, tan theta, is equal to the sine of that angle divided by the cosine of that angle. Sine theta over cos theta. So after getting these two, we have 1 over 2 sine 30, 1 over 2 cos 30 root 3 over 2. All you need to do is to find tan 30 degrees. All we need to do is say 1 over 2 divided by root 3 over 2. So tan 30 will be 1 over 2. When we change this to multiplication, 2 over root 3. 2 crosses out 2, and we get 1 over root 3. That is tan 30. That's how to get the tangent using the finger style. So it works for any type of angle. Sine over cosine is equal to tangent. Now, Onyeka, what if you have the answer in decimal? Can you convert to surd? If the answer is in decimal, can you convert to surd? Okay. I think you asked that question because you don't understand what surds are. A surd is a decimal number that cannot be expressed in fraction. Surds are numbers that cannot be expressed in fractions, like the square root of 2. If you punch for a calculator that can accommodate 20 digits, 20 space digits, you will continue having your numbers. The space will get exhausted. For a calculator that can accommodate a space of 35, a space of 100, if you find the square root of 2, it will exhaust the whole 100 spaces. So it means that the square root of 2 is a decimal number that continues to infinity. It has no end. We have numbers like pi. Pi is also a decimal number that continues to infinity. So, pi for instance is 3.14159.265. This is just to a few decimal places. We can't convert this to fraction. No, we can't. So that's why it's important you know it in surd form, because you can only convert your surd to decimal. You can only convert your fractions to decimal by approximating. You truncate the decimal places because you can't fully write them in decimal. So you can convert a decimal number back to surd, except you already know, for instance, sine 60 is root 3 over 2, which is in decimal 0.8660. But this is not all. This is not all. It continues. But this is the most important part, and so we leave it like this. If you convert this back to fraction, it will be close to sine 60, but it will not exactly be sine 60. Do you understand? So we can't particularly convert a decimal number to surd. Okay, good. Nonso is asking for example 2. Okay, maybe you have a problem. You had a problem with your network. Example 2. Let's see. Yes, example 2 is asking us to find the value of cos x find cos x, find tan x, and the third one, find sine squared x plus cos squared x. This is example 2. From SOHCAHTOA, I believe you know what SOHCAHTOA represents. Sine theta or sine, whatever angle you have, is equal to opposite over hypotenuse. And so I said, since you've been given the fraction, all you need to do is construct a diagram for yourself. Sine x, that means the sine of a particular angle. You don't look for the sine of the length of lines. No, it is the sine, cosine, tangent of angles. That we look for. So sine x is equal to opposite over hypotenuse. I said we should put the opposite as 3 because opposite is in the numerator and the denominator contains the hypotenuse. So we'll put 5 here. If we are now looking for cos x from SOHCAHTOA is adjacent over hypotenuse. So we need to find the adjacent from Pythagoras theorem. Using the Pythagoras theorem, we are going to have hypotenuse squared is equal to opposite squared plus adjacent squared. So our 5 squared is equal to opposite, which is 3 squared, plus adjacent squared. I believe we can make unknowns the subject of formula. From here we have 25 minus 9 is equal to adjacent squared. 16 equals adjacent squared. At this point, we take the square root of both sides. 4 is equal to adjacent. We got our adjacent to be equal to 4. So now we can write 4 as the adjacent. To find the value of cos now, to answer the question itself, cos x is equal to adjacent over hypotenuse. And so we can say cos x is equal to, what is our adjacent? Adjacent is now 4. We just got that from Pythagoras theorem. And hypotenuse is 5. So cos x is equal to 4 over 5. We have tan x. Tan is opposite over adjacent. Opposite over adjacent. That gives us opposite, which is 3, over adjacent, which is 4. And finally, sine squared theta, sine squared x plus cos squared x. We're told to simplify. What's sine x? Sine x was given as 3 over 5. So we use 3 over 5 and then square it plus cos x. We got that as 4 over 5. 4 over 5 and then square. This gives us 9 over 25 plus 16 over 25. When we add this together, we have 1 as our final answer. 1 as our final answer. Okay, we have praise. Tan theta is equal to 16 over 63. That's absolutely correct. Praise is actually correct. Ratio, your first answer, you got 52.51, which is very correct. And question 2, you got 44.7, which is not correct. Which is not correct. I'm sure you've seen the correction to the problem. Abby, you had 52.5097, which is absolutely correct. You had your value to 4 decimal places. Very good. And then your final answer, tan theta is equal to 0.254. 0.254. Okay, your answer is in decimal. It's still very close, but it is not acceptable. Your number one answer is correct. Number two answer is correct too, but it should be in fraction. When you are given this kind of problem, your expected answer should be the exact format. So 16 over 63 is actually correct.